Good day, everybody. Today we're going to do a little experiment. You could do this at home. All I've got here is a piece of 18 gauge thermostat wire and a 9-volt battery, just a standard battery. You can buy one at the store, and a carriage bolt. You could use any kind of bolt, screw, metal rod, whatever you wanted to use. Just some sort of ferrous metal material. There's another one you could have used. Just anything made out of iron. So I'm going to take this, I'm going to make an electromagnet. So I'm going to take my wire and I'm going to wrap it many times around my bolt. So there I am wrapping it many times. You can do this at home, easy. Usually in our face-to-face labs, I have students do this. Scrunch them together. Keep wrapping. The more wraps, the better. I'm thinking that's probably pretty good right about there. A couple more maybe. There we go. Now I'm going to grab my wire stripper and I'm going to, basically I'm just going to make the ends so they're even. And cut off the long one. Just makes it easier to apply the power to it. And I'm just going to strip the ends back to expose some bare wire. Easier said than done. There we go. So all I'm going to do is apply voltage, power, to my wire. And what that does is there's a magnetic field around a wire that's formed when power is applied to it and you have voltage and amperage flowing through your wire, which you're going to learn more about in David's class. What that does is all these wraps magnifies that magnetic field and creates something called inductance. And we're going to actually magnetize the metal rod. It'll create a magnetic effect. Believe it or not, this relates to forced air heating. So there I am putting my 9 volts on it, and my dealie is magnetized. I picked up one washer. Look at there, I picked up 2 washers. And that electricity is flowing through those wires. It's wrapped around many times around that around that iron rod, and it creates a magnetic field. There, I picked up 2. 3. Picked up 3. Awesome. Picked up 3 washers. As soon as I take power away, boom, they fall off. And all it is a 18 gauge thermostat wire wrapped around an iron core. And the same thing is done in the HVAC industry. This is called a coil. You would nickname that a coil. And we do that to make work. So here's a gas valve. This is the same exact gas valve that's on our furnaces. And you see what I'm pointing at there is really, really fine copper wire wrapped around a magnetic core. Probably a couple thousand wraps on there. And what that does is it creates a magnetic field when power is applied to it on those 2 leads. There's a core in the middle, and that opens a valve inside of our gas valve. That's what allows gas to flow through. There's my inlet of my gas. It flows through the gas valve and out to our burners. Pretty cool, eh? And so that's a spring-loaded valve. So when I de-energize this, when power is taken away from that magnetic coil, my gas valve slams shut. my gas valve shuts. If I took the top off, you can't see the valve here per se, but trust me, in the top of this there's a basically like a needle valve, and when that shuts off it interrupts the flow to our burners, and it's all done on that coil, and it's done through magnetism, inductance, low voltage, many reps. So there I am pointing, showing that the valve shuts, it slams shut.